I need to cover chapter 5 today, section 5.1. There are some formula that we need to apply in these sections. One is when you have numbers with the different power and the same base. Let's say I write this number 5 to power of 3. 5 is the base and 3 is the power, or we call it also exponent. Five to power of 3 means I'm taking 5 and multiply it by itself 3 times. So exponent or power indicate how many times you take the base and multiply by itself. So let's say you have 2 to power of 4. 2 to power of 4 means you take 2 and multiply by itself 4 times. All right. So now, one of the formula is if you have the same base and a different exponent, you write one base and add the power or add the exponent. So let's say you have here 3 to power of 2 times 3 to power of 4. According to this formula, it's equal to 3 to power of 2 plus 4, or 3 to power of 6, whatever that number is. But remember, rather than memorizing the formula, you could do it this way. If I expand 3 to power of 2, 3 to power of 2 means this, 3 multiplied by 3, right? And what does 3 to power of 4 means? You take 3 and multiply by itself 4 times. So altogether, how many times do I multiply 3 by itself? 3 to power of 6. So we don't really need to memorize the formula as long as you understand how to expand. Okay? So in that case, let's say you have z to power of 6 times z to power of 2. Again, expansion of z to power of 6 is what? Is just you have z multiplied by itself 6 times, and you have z2, which is that, right? So we are taking z and multiply by itself 8 times. Or according to the formula, is z to power of 6 plus 2 is equal to 8. What is 6 to power of 9 times 6 to power of 3? It's 6 to power of 9 plus 3, or 6 to power of 12. And then you could use your calculator and estimate that number. But here we just want to make sure you understand how to take a number and raise it to the power. So this is like very, very large number. All right, okay. And that's also true when you have a bunch. Let's say you have here x times x to the 8 times x to 9. When you don't see any number, it means it's always 1. If you don't see any power or exponent, it always is 1. So that would be what? X to power of 1 plus 8 plus 9, or x to power of 18 . So that's this formula. So we discuss a to power of n times a to power of m is n plus m. Okay. Now, what if you divide? In that case, you write the base and you subtract the power. This is a formula when you find a ratio or when you divide. Again, this is a formula that you could, if you expand it, you may figure that out yourself rather than memorizing the formula. For instance, if I have 5 to power of 3 divided by 5 to power of 2. I want to divide these two. 5 to power of 3 is, you'll repeat 5 3 times and 2 times here, right? Cancel, cancel, cancel from numerator down. What is left is just what? 5. Or if you want to use the formula, they both have the same base. See, base is 5. They both have the same base. You just write one base and subtract the power. You could also do it this way too, if you want to follow the formula, right? X to the power of 3 divided by x to the power of 4. Isn't this x times x times x and x times x times x times x? Now remember here, 3 x's cancel. What is left at the bottom is just 1 x, right? And what is left at the top? You should always put a 1. Don't just say it's nothing there. Like if you have 3 divided by 6, let's look at this. You write it as 3 and 3 times 2, right? And when you cancel this, what is left at the top? Always 1. You can't just leave nothing here, right? So remember, in this case, denominator has 1 extra x. So that would remain here. x11 divided by x8. 8 of them cancel, right? So do I have to list it all here? So what is left is what? X to the power of 3, right? So you take x multiplied by 7, 11 times, 8 times 8 of them cancel. What is left is 3. Let's look at this one. I want to simplify this. So in a case like this, let's just hide a variable first. What do you see here? -6 divided by 2. Doesn't 2 goes to 3 times? So you have -3, correct? At the top. Now look, Z5 and Z9, how many Z's left and where? The top. Nothing at the bottom. So it would be what? minus 3z to power of 4. X4, Y7, X2, Y7. Y7 and Y7 cancel. X2 and X4. That would leave just X2, right? Because you write X 4 times and 2 times, 2 of them cancel. So what is left is X to the power of 2. How about P to power of 6 divided to P to power of 9? 6 of this, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of that. Cancel, cancel. What is left is what? P to power of 3 at the bottom, right? Because you have 9p here, but just 3 here. So it's 1 over P to power of 3. Now this is a combination of all, look. All right, let's look at this. I want to simplify this. And what they're saying is use the quotient rule. Use the quotient rule to simplify. What is quotient rule? No, it's just this one. We talk about it, right? But rather than worry about the formula, again, just think of this. First, let's take care of the numbers. What do you have here? Minus 15 over 3. Isn't that minus 5? Right? Negative 5. Now look here. A3 and A5, it gives A2. B2 and B4 leave B2. C6 and C9 is C3. Nothing left here, and you already have negative 5. Nothing left at the denominator, so it would be minus 5, A2, B2, C3. All right. Then another subject is this. What is 3 to power of negative 1? Some student by mistake, they just say minus 3. No, that's not true. Let's look at this. What is 3 to power of 1? 3. What is 3 to power of 2? 3 times 3, which is 9. What is 3 to power of 3? 3, 3, 3, 27. 3 to power of 4, right? And what is 3 to power of 0? Well, can I take 3 and multiply by itself 0 times? No, it's meaningless. When I say 3 to power of 2, 2 is indication. The power means you got to take the 3 and multiply by itself 2 times or 1 time or 2. But what about 0? This is the definitions, okay? If you want to know what is 3 to power of 0, use your calculator. In your calculator, type 3. I don't know what type of calculator you're using, but use the power and put that 2. The calculator would give you 9, right? Let's test it first. Now you type 3, use the power. Again, some calculator is like this. You have to know which one is the power. And put 0 now, calculator would give you 1. It means any number or variable to power of 0 is always 1. So what is 125 to power of 0? It doesn't matter what the base is, calculator always give you 1. How about minus 1100 to power of 0? 1. What about x to power of 0? 1. What about x plus 2y power of 0? It doesn't matter what the base is. The outcome is always 1, you know? And again, you can use your calculator. All right. So 3 to power of 0 is 1, according to definitions. 3 to power of 1 is 3 to the power of, okay, what about 3 to power of negative 1? Like 3 to power of negative 2. I know that I cannot take the 3 and multiply by itself negative times. Multiply by itself negative time is meaningless. When I say 3 to power of 3, then you understand you got to take the 3 and multiply by itself 3 times, but you cannot take a 3 and multiply by itself negative times. So there is a formula. Anytime you have a negative power, you could change it to the positive power by reversing it. So if you want to change it to the positive, it has to be 1 over that, which is 1 over 9. You see? So here, 3 to power of negative 1 is 1 over 3. Okay? So this was formula number 3, right? Okay, what about if you have minus 5x to power of 0? Let's look at this one. Remember, this one is 1, not negative 5. I want you to understand the difference between this and this one. Look. When there is a parenthesis around the whole thing to power of 0, this is the one which is 1. But here, just this part is 1. So what is the outcome? Minus 5 times 1 is negative 5, okay? So be careful. If you see a parenthesis around the whole thing to power of 0, that one is 1. Like here, negative 3x minus 8, the whole thing to power of 0. 1. But 4z to power of 3 plus 3, look at this example here. 4z to, see, z to power of 3 is 1. This 4 is not a part of this. So it would be 4 times 1 plus 3 or 7. All right. So we talk about the formula that if you have a negative exponent, you have to change it to the positive exponent doing this way, right? So what if I have something like this? 5 to power of negative 3 over 5 to power of negative 7. Now, 5 to power of negative 3, if you want to change it to the positive, is 1 over 5 to power of 3. And the other one is 1 over 5 to power of 7. And then you multiply these two and these two. These two are further away from the other numbers. So that would make it 5 to power of 7 divided 5 to power of 3. Cancel, cancel is 5 to power of 4. Okay. All right, so but rather than going through all this, you could also do it this way. Look, in this formula, if your negative power, if as numerator, all you need to do is switch it to the denominator. That's what happened here. You see that? And vice versa. So another way to do this problem is, rather than doing all this, just say 5 to power of negative 3. If I want to switch it to the positive, it has to go from numerator to denominator to be positive. Vice versa, if 5 to the power of negative 7, we want to be positive, you got to go to the numerator from the denominator. So you could do it this way too. It's easier. So let's look at this one, another example. Z to power of negative 2 divided by z to power of 7. This is negative, right? You want to bring it denominator to change it to the positive. Don't touch the z power of 7. Z power of 7 is already positive, so stay here. Just the negative one, you switch the negative one, not the one that is already positive. So that will stay here, right? So what do you have now? Z2 and Z7, which is Z to power of 9, right? Remember we expand this 2 times and this 7 times, we write this 7 times. That's how you do it. So again, be careful. Do not touch the one that is positive. You leave it there. Three, z to power of negative 10, z to power of 4 over z to power of negative 6. Look at this one. Just move the negative one, okay? Do not touch the one that is positive. Don't touch this one. It's positive. You stay here. Z to power of negative 10, whoop, switch. Z to power of negative 6 moves up. So what do you see here now? Z4 times Z6. Remember? What is Z4 times Z6? I just remind you one more time. 4 times here, 6 times here. So Z to power of 10, right? So the top one is Z to power of 10. Bottom one also is Z to power of 10, right? These two cancel, so it's 3. Simplify this. All right, so before I simplify, I try to move all the negative one. Switch all the negative one first. You see that? The only one that are negative are these guys here. Okay, so you switch those here. Okay, then you simplify. 4 goes to 8, 2, B7 and B4. 7 of the 7B here and 4 is B to power of 11, A to power of 9. You want to simplify again? And he said you want to always leave the positive power. Do not leave the answer with the negative power. Always use positive exponent. The answer should not have a negative exponent for any variables. All right. The only variable which is negative is this guy's here. So move it from denominator to numerator. And just 20 and 24, they both are divisible by 4. So you have that. Again, remember, just the negative power would move. So 8 is positive, don't touch it, just leave it there. But c to power of -3, you got to bring it up. So nothing left at the bottom is c to power of 11. All right, so that would be end of 5.1, section 5.1.